12 today. Never could tell. And if we did, that would be, I mean, next week would have to be lab days. And then you could catch up on your labs. That'd be all right, right? This is chapter 12 of the digital circuit class. And where the, if I could spell circuits. And we have 3 days to do it. So that's totally amazing. How can it possibly take 3 days? So the first thing we have to deal with is a counter. And you say, okay, well, you just showed me a counter, and we had a JK flip-flop, and another JK flip-flop, and another JK flip-flop, and another JK flip-flop, and we had all these wires going around. And I'm going to say, well, that's nice, but what we're going to do is we're going to put the counter in one package. So there's one package of counter, and what is it going to do? It's going to count. See, what are we going to do? We'll have a 10. So we have a 10 counter. So what's going to happen is that we're going to have one side, which is a divide by 2. And if we take the output of that side, and that doesn't look like output, of that divide by 2, and we send it into the bottom half, we get a divide by 5 out of him, and then the most significant bit coming out of the bottom, so that'd be Q 0, 1, 2, 3, Q3. That would give me a divide by 10 of whatever signal I was sending in. So I got some input. And you say, wait a minute, if I have a counter, how come it's a divide by counter? That doesn't make any sense. Who made up this stuff anyway? But I could do that. And then I'd have another guy here, Q2, and another guy, Q1, and this guy here would be Q0 because he's the top guy. And Q2 would give me, what would it give me? Divide by 8. And this would give me divide by 4. That's really bad. Somebody's going to have to teach the instructor how to make a divide sign. And then, but all I need is one input in. But I got a second input over here, which is for the second part. So I could have gone and skipped the divide by 2 and just came in here as my input. And then I'd get divide by 2, divide by 4. And what would that guy be? This would have to be a divide by 5. All right. I could make a divide sign, which I can't. We already know that.
I just put a slash.
Oh, that would be so much easier, wouldn't it? All right. And then, so that's what we have a divide by 10 counter. Or if we didn't, we could have a divide by 12. We could do that. Divide by 12. Oh, I tell you. Oh, that's the problem. Somebody turned on the touch and my fingers are moving it around. I didn't think it was me. So we could have a divide by 12 counter. All right. And if we did, we'd have a top half, which would be a divide by 2. We could have input A coming in. And coming out, we could have divide by 2. And then coming out at the bottom at the QA guy would be QA. We don't want QA, Q3. Q being the output. We could have a divide by 12 if we brought him into the other input spot, input B. Or we would have a divide by 6 if we just came into that spot, if my input just came in directly. All right, so we can have those guys, and we can do the same thing with a divide by 16 counter, And we'd do the same thing. We'd have a divide by 2 on top and a divide by 8 on the bottom. And they're separate counters, and they're normally put together to get to 16. And then you'd say, well, what if I wanted something cool? I don't know what do I want cool anyway. I don't have my calculator with me. So, yes, I do. Here it is. I just found it. So I've got 8 times 10 times 6. So I want to divide by 480 I want to divide by 480 counter. That's what I want. So how am I going to do that? Oh, well, I don't know. So if I go and take a divide by 10, and I bring my 480 in to the input A guy, the first A guy, and then I bring my Q0 out and bring it into input B, then I could get out of this guy I'm going to already get to, that's divide by 10, divide by 48. So I got to divide by 10 already. All right, now I got to get a divide by 48. So how do I get to 48? And I look at 48 and I say, well, that's 2 times 24, 2 times 2 times 12, right? Okay, so I'm going to make myself a divide by 12 counter. So I'm going to divide, oh, there we go, divide by 12. No, that's dumb. So I got to divide by 12 guy. I bring this signal into the A input. I hook the 0 output into the B input, and now I've got a divide by 120. So now I only have 4 to go, so I'm going to get 4. Well, I can go back to another divide by 10, bring that into the A input, bring the 0 output over into the B input, and then that's Q0, Q1. And now coming out of Q1 would be divide by 480. And then you say, well, why would I want to do that? You know, what is an application for something that's dividing? Well, let's say I have a checking account and I want to steal your money, and I steal half of it at a time, and I have some counters set up to count down some number of days so I can, that application. Okay, well, I guess we'll skip the application. Now, for the math part of the situation, I've got this, I have a situation where I want to divide by 480. Oh, we won't do that. We'll do something different. We've got things called modular math, mod math. So we're going to do mod 8 math. Okay, so mod 8 of 1 is 1. Oh, that was good. You like that one? And then mod 8 of 3 is 3. All right. Okay so far? Okay. Mod 8 of 9 is 1. That was good. I like that big eraser. That was really cool. It just took everything away. Okay, so yeah. So I got in my mod counting, I got a 0, I got a 1, I got a 2, I got a 3. This is mod 8. I got a 4, I got a 5, I got a 6, I got a 7. But when I get back to 8, I'm back to 0, and now if I go to 9, then that's a 1. So I got mod 8 of 573. And I have one choice. It's between 0 and 7. Okay, so whatever this number is, it has to be between 0 and 7. Okay, so I'm going to take, there's my calculator. 573 divided by 8. Did. All right, so where are we? So this would be the same as mod 872. I recognize 72 as something multiplied by 8. So this is going to be 0. That's impossible. That can't be. This is an odd number. How did I?
573.
I put in the wrong number in the calculator? Well, at least I recognized my mistake. Or someone recognized my mistake. 573 divided by 8. Oh, that's better. Alright, so that'd be a 71, and make this a 7, right? 7. So mod 8 of 573 is a 7, maybe. Yeah, I think it would be, yeah. Okay, so that's good. So I'm going to have mod 8 of 9 times mod 12 of 37. All right, well, there we go. That's good. So mod 8 of 9 is a 1, and mod 12 of 37 is a 1. So the answer to the problem is 1. Yeah, because 36 is 3 times 12, and so, yeah, mod 12 of 37. Now, I don't have my calculator. I think your calculator does do mod math, but I don't have mine, so I can't show you how. All right, so that was just what you needed to do. Okay, now, if I go, and I've got a bunch of JK flip-flops. And so I got this clock thing, CK, 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 CK. And I got a clock out here, clock pulse, and it hooks up like that. What would we call that counter? We would call it synchronous. It happens when the clock happens. Okay? CHROYNOUS, no way, but something like that. Right. But what if we had JK flip-flops lined up, and I got the clock coming into the first guy, and then I have Q1 going into the clock, and I have Q going into the clock, and I have Q going into the clock. Now it's not all happening at the same time, right? So we would call this, because I'm on page 538, we're obviously going to call this sequential. SEQUENTIAL. So these guys are happening one right after the other. All right, so we have, I got a JK flip-flop, J and K, and I'm going to take J and K and I'm going to make them both 1. So that makes it what is it called? I forget. Toggle. Okay, so it's going to toggle, and I'm going to have a clock pulse out here, and I'm going to take the Q, and I'm going to take that Q and go into the next JK flip. No, I'm going to put it in the clock. Okay, so I'm going to go and put it in the clock. And then I'm going to take the Q out of that guy, and I'm going to go put him over in the clock. And then I'm going to take the Q out of that guy, and I'm going to go put him over here in the clock. And what am I going to do with J and K? J, K, J, K. J, K. Oh, I was stupid. Put the K there. And I'll make those guys 1. 1, 1, 1. So now I'm going to toggle Q. So I got Q, 0, Q, 1, Q, 2, Q3. All right. And just for the sake of argument, I'm going to be at 0 for everything. Okay? And the clock pulse happens. Boom. What happens? Well, this guy toggles. Boom. Wait a minute, that guy toggled. Boom. This guy toggles. Boom. That guy toggles. Boom. We just went from 0, 0, 0 to 1, 1, 1, 1. All right. Going to happen again. Clock pulse happens again. He toggles to a 0. Nothing happens. Nothing happens. Nothing happens. All right, we toggle again. Boom. He goes up. He goes down. Nothing happened. Nothing happened. We go up again. He toggles. He toggles. Nothing happens. Nothing. Wait a minute. He toggles. Nothing happens. Yeah, that's better. It happened again. Boom. 1, 1, no, 1, 0, 1, 1. Okay, that's going to make this guy toggle to 1. Those guys are going to, something's wrong with my analysis of the situation here. That wasn't supposed to happen. All right, so I had 1, 1, 1, 1. This guy toggles to 0, nothing happens. Okay, so everything was fine until I got here. He toggles to 1. He toggles to 1. He toggles to 0. There we go, and that guy's 1. All right, now I'm happy. It happens again. Boom. 0. That 0 means he stays the same. That 1 means nothing happened. And nothing happened. All right, that's good. And anybody see the pattern yet? Anybody see the pattern yet? Oh, probably not. This is the most significant bit. This is the least significant bit, and I am counting down. So I went from 0 to what is that, 31? Is it 31? No, it's 15. So I went 0, 15, 14, 13, 12, 11. Next one's 10, 10. Then I go 9, and then I go 8. So now I'm going to do it again. That was so much fun. So I'm going to have my J and my K are both going to be at 1. My J and my K are both going to be at 1. My J and my K are both going to be at 1. I'm only going to do 3 of them this time so I don't get confused. And I'm going to have a negative going clock this time instead of a positive going clock. That last one was positive going clock. I'm going to have a negative going clock, and I'm going to take Q and put it into my clock, and I'm going to take Q and I'm going to put it into my clock. And then I'm going to have a clock pulse out here coming in there. Okay, so I'm going to start at 0, 0, 0 again. And then I'm going to go and have the clock go down. All right, so the clock happened. I'm going to toggle 1. Okay, that 1 goes into here. Nothing happens. Nothing happens. Nothing happens over there because nothing changed. Boom, boom. Okay, the clock pulse happens. Boom, he toggles. Ooh, that 0 triggered this guy. He goes to 1. That 1 comes into this guy. Nothing happens. Okay, the toggle happens again. the down clock pulse happens again. He goes to 1. That 1 becomes a 0, so nothing happens there, nothing happens there. And clock pulse happens again. Boom, toggle. He went to 0, so this guy toggles down to 0. That guy toggles over to 1. And now I have an up counter. Up. I can spell up. Okay, so this is my most significant bit. This is my least significant bit, so it's written backwards, but I go 0, 1, 2, 3, 4, 5, 6, 7. I keep on going. So the difference between counting up and counting down is whether or not I have a positive edge trigger or a negative edge trigger clock. Okay, so that's kind of interesting. Not that interesting. Okay, so now we got a weird thing on page 540. All right, so we'll do the guy on 540 because he's sort of interesting. All right, so I got, and besides, there's only 2 lousy flip-flops there, right? So I got 2 lousy flip-flops. 1, 2. I got a clock pulse. And it's a negative trigger guy. I have a set, and I got a reset. Now, this is interesting. They have the set is knotted, and they put the reset in here as not knotted, because if the reset was on the other side, it would be knotted. So that's kind of cool that they did that. And then I got a Q0, and my Q0 is going to go into the negative clock of the other guy. All right. And now we, okay, we're going to have a J and a K that are both 1. Okay, so that guy's set up for toggling. And now I've got 2 AND gates. 1, that doesn't look like an AND gate. That looks like a square box. Oh, much better. Okay, 2 AND gates. I got an A coming into those 2 guys. All right, I got that. Okay, I'm going to take Q1. And I'm going to bring him into there. And I'm going to take Q0. I'm going to bring him into there. And then I'm going to take that AND gate into the K. And the other AND gate into the J. And I'm going to put a 1 on the reset guy. And we're going to put kind of an SD naught guy sitting there. Okay, so picture is fine. All right, so now I have things going on. And I won't be able to do anything because I can't possibly see enough of this, right? Oh, well, just another cross to bear. So I got one signal doing that, and that's the set naught. Okay, so that's both of these guys are set naught. So that means that they're going to set Q0 and Q1 are both going to be high as I start the problem. And okay, so I'm going to remember that. So I'm starting it at 0, 0 because of that guy. And then I've got a clock pulse that does 7 things. Okay, so 1, 2, 3, 4, 5, 6, 7. And the only thing that time things can change is going to be negative clock pulses. So I'm going to put a DID on top of the negative guy so I know that's what I'm looking for. And then I've got the A guy. Okay, so the A guy is going to start low, and then about there it's going to go high, and then at the 0, 1, 0, 1, 2, 3, it's going to go low, and then it's going to go up in the 6 guy, and you're going to go down in 7 and stay low there. Okay, so that's what I got. And then the question is, what is J1? Now the book already told us what it is. K1, Q0, Q1. So that's what we're looking for. Okay, so because I reset, let's get a line. We're going to put some lines in. Yeah, we'll use that guy. Okay, so something happens there, and there, and here, has a potential of acting in those places. Well, that was bad. That's not even a straight line. What if I can make it straight? No, I can't. Yes, I can. Oh, much better. Oh, that is just so Marby. Okay, so I got straight lines. Because the set guy is happening, Q0 and Q1 are both going to be high. We'll go with red for them. Q0 and Q1 are both going to be high. Okay, and the next thing that can happen, they have to stay high until that's high, and this is high, until the clock pulse happens. Then something could happen. Now, Q1 and Q2, K1, K2. All right, so Q1 is high and A is low. So when A is low, this guy's going to be low. They're both going to be low. So both of these guys are low because A is low. Okay, now the clock pulse happens and Q1 toggles because Q0 toggles when the clock pulse happens. Okay, that's good. Go back to red. I'm in red. Okay, so I'm going to toggle him down. Q1, nothing happens because I got a 0, 0 there. Nothing happens. He stays high. Okay, now when A goes high, what happens? We're going to stay, J1 is going to still be low because Q1's high. So when Q1 is high, so let's change color. All right. So J1's going to go high. All right. And K1 is going to stay low because Q0 is low. Okay, excellent. Now the clock pulse happens. The Q0 is going to toggle. It has no choice, so it's going to toggle. Oh, where is it? There it is. It's going to toggle high. Q1 is going to set because I got a 1, 0 on JK. So Q1 is going to set. He's already high. He's going to stay high. Okay. Now, J and K. Q0 is high. A is high. So K1 is going to be high. Q1 is high. A is high. J and K are going to be, J and K both are going to be high. The toggle happens. Both of them toggle. Toggle low, boom. I didn't want that color. And I didn't toggle the right guy low. Toggle, oh gee, I don't believe it. Hard to believe. Boom, boom. Okay, that's better. So we're in red. Going to toggle low on both Q0, and Q1. Okay, now A went low. As soon as A goes low, both J1 and K1 have to go low again. Okay, toggle happens. Toggle happens. Q0 goes high. Q1 stays the same because we're at a 0, 0, which is a hold. The clock pulse happens again. It toggles for Q0, but I'm still on a hold. Okay, so I'm 0 across there. I'm 0 across there. I'm 0, 0, and the A gives me a 0. A is the one, it doesn't matter. I'm an AND gate, so I'm still going to be 0. I'm going to toggle. I'm going to hold because J and K are both 0. I'm going to toggle again, and I'm going to stay at 0. Now, is that what they say? Oh, look at that. Totally awesome. Same picture the book has, except for someplace. What's wrong with my J and K? How come I didn't go up or something? Oh, yeah, I have to go finish the song. So this guy would do that. And that guy would do that. Okay, there we go. Perfect. Now that type of problem is on your next test. Going to be, you know, what does this guy do? All right. So, next problem, 554, ripple counters. Ripple, something that looks like that, or is it something you drink? I don't know, one or the other. R-I-P-P-L-E, ripple. That sort of means asynchronous. Yeah, I'm pretty sure that's probably what that means.
You do an example
So,
for it?
oh, I'm going to, yeah. Oh, yeah, it means asynchronous, yeah. So we look at page 543, and we have a 3-bit binary ripple counter. And it goes 0, 1, 2, 3, 4, 5, 6, 7. Okay, that's fine. And but you notice that it's not synchronous. But all those guys are, and yeah, that's all we're going to do. All right, well, yeah. So that's all there is to it. Wow. What if I should draw that picture? I guess I should. Nah, that's too easy. Why don't we look and see if we have something else? Oh, that's better. Page 544. We have 4 of them. I wonder if we can go and build that in Multisim and see it work. I think we can. Anybody know what the JK flip-flop number is? You don't remember? 74, 76? That's what I was thinking too. I was thinking it's probably 74, 76. Could very well be. And this time, well, this will be, I've never done it this way before. Whatever this way is, it's going to be different. No, not that different, but it's going to be different. I can just feel it. Okay, so view, zoom to something, right? Wrong way. Okay, so I filled the screen, and I need 74 76s. Negative going clock. Okay, looks like the right guy. So I need 1, 2, 3, 4. All right. Then we're going to do put a bus around it. Oh, that's dumb. There, okay, get rid. So where's our bus? There's our bus. Okay, so we're gonna run a bus around it. Is that enough? Oh, dummy. Go click. Yeah, I got a bus. All right, now I got a bus around it. Okay, excellent. I need VCC. So there's VCC. And we're going to run it into the bus. And I'm going to call it line 1. We'll just call it line 1. Okay. And then we're gonna have to hook up VCC to there, and all we have is line 1, and we got to hook it up to here, and all we have is line 1. And we have to hook it up there, and all we have is line 1. We have to hook it up there, and all we have is line 1. How about the guys on the bottom? No, guys on the bottom we don't. Okay. Then I'm going to need a switch. All right, so we'll grab a switch. Where's my switch? All right, one switch. And I'm going to need a ground. Okay. And I'm going to need a pull-up resistor. Where am I going to get a pull-up resistor from? I'm in sources. It's not there. Must be these guys. Anybody see a pull-up resistor thingy? I gotta make my own. I know there is one. I just can't find it. Okay, so there's a 10K guy. All right, so put a 10K guy here. Excellent, excellent. Okay, so there we go. We're all set. We're gonna hook him up to VCC. We come across the switch, and we hook it up to ground. And we blew it. Darn. Place a junction right there. All right, so we come up here and cancel. Come on the bus. Come up bus. We want to add something. What do we want to add? Add a bus line. Boom. What's the name of the bus line? RD naught. No, just RD. RD. All right, there we go. RD. Okay, now we can come up here, go over there, call it RD, and hook up these guys, all of them. RD, RD. Anybody asleep yet? RD. Anybody want to come here up here and do it for me? RD. Yeah, that's what I thought. I heard that. RD. Okay, so we got those guys hooked up. Now I need a clock pulse. Where's my clock pulse? Current. No, it's got to be here. Power source. Oh, power sources. No, I don't want that. Signals. Oh, there we go. FM clock. There we go. Clock. There we go. I got a clock pulse. So it is. Put a clock pulse there. Excellent. Hook up one side to ground. Come up to the bus bar. Yeah, maybe I can do that. I don't know. Oh, line 3. There we go. Line 3. And what am I? It'll probably just give it a universal setting. Okay, that's good. And then we're going to put a clock pulse over here. And we know it's line 3 because we remembered that. All right, excellent. That's the only place we need that. We need a bunch of 1s on all of our J's and our K's. All right, so VCC. 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 We'll come up to there. Boom. VCC. Thank you very much. And, okay, that looks good. And then all we have to do is hook the Q's up. All right, so Q to there, Q to there, Q to there. Am I done? Or not? Oh, it doesn't work. Oh, bummer. What am I doing wrong? How do I even know it doesn't work? How did he do that? Well, I know it doesn't work because it doesn't have a DC ground yet. It needs a digital ground. All right. So I need a digital ground someplace on it for it to work. Okay, there we go. Now it will work. Okay, now I'll turn it on, and boom, and clearly it's working now. Okay, no problem. Right? Okay, so we made that up. Now we need to get our thing to. You don't trust me, do you? Bunch of guys, anyway. All right. All right. Well, we'll do it this way just to make it easy on ourselves. Okay, so we're gonna get a. Where is it? Probe. What color do we want? We want a green one. Okay, so we'll put a green one there, and we'll put an orange one here, and we'll put a red one there, and we'll put a yellow one here. And we'll boom. Boom. Missed it. And here. And there. All right, so now is everybody happy now? All right, so do that. Hit my switch. You happy now? It's running. Not that happy because it's running too fast, right? All right, so we'll sit back and see if we can make it run slower. 1K, and we're going too fast, so let's put it at 10 hertz. Think that'll be okay? And hit that guy. Yellow, there's 1, there's 2, there's 3. Is that what it's supposed to do? 4, 5, 6, 7, 8, 9, 10, 11. Now, was that better with the bus bar? It took away all those heavy wires and everything. Okay, now, but that's not what we really want to see. What we really want to see is we want to see it on the logic analyzer. Is that what it is? Oh yeah, that's what we want to do. We want to use the logic analyzer because this is going to give us the picture that's on the bottom of page 544. Okay, so there's the logic analyzer. And we're going to bring what are we going to do? Okay, so we want the clock pulse to come in the top guy. Okay, where the heck's the clock? Oh, yeah, we just moved it over a little bit. Oh, I have two of them. That's cool. We'll get rid of one. All right. So I'll go get the clock pulse. Yeah, I should be able to go on there. Boom, clock. Oh, bummer. Which one was the clock? Line 3. Okay, so I got the clock pulse, and then I want the 0 guy next. All right, so what we'll do is no, we won't. We'll just go in and get the 0 guy. So we're going to get the 0 guy. Maybe we'll get the 0 guy. Boom. And then the next guy. I missed him. I don't believe it. All right, that's better. And then we'll go get that guy. Oh well, I knew I should have used the bus bar. Get rid of this pen. There we go, use the mouse. Okay, so that's good. All right, now if I look at this guy, I see that that doesn't do me any good. I see that the setting of the clock, the internal clock, is set for 10 kilohertz, and my clock is only going at 10 hertz. So if we accept this at 10 kilohertz, then we should reset the clock to a reasonable speed, like 1K. So we'll reset the clock to 1K. That'll be good. Now that'd be too fast for us to see, right? So we turn this guy on, and you know, it's going too fast, right? But if we bring this guy up and we turn it on, and it's still going too fast. What a bummer. But we can go and we've captured all that. So the top guy is my clock. So let's cut the clock divisions down. And where do we start? We start at 0, 0, 0, right? All right, so if we start here at 0, 0, 0, then he goes up, and he goes down, he goes up, and let's set the clock a little more and see if we can see everybody. There, now we got everybody in the same view. So we started at 0, 0, that's not 0, 0, 0. There, here's 0, 0, 0. Let's move over just a hair. 1, 2, 3, 4. Okay, so we started 0, 0, 0. How come that guy's 1? Where's 0, 0? There's 0. I found it. Bummer. All right, let's find 0, 0, 0. Almost. There we go. So there's 0, 0, 0, and then we have a 1, and then we have a 2, and a 3, and a 4, and a 5, and a 6, and a 7, and an 8, and then we keep on going. 9, 10, 11, 12, 13, 14, 15. Okay. Happy with that? So I can, in fact, build the circuit and work it on multisim. I do have the piece of equipment that is on page 544 if you want to use it in the lab. When I bought it in 2000 for a mere $3,500, and it'll do 36 channels and look at this the same way that that does. All right, so on page 545 we have a mod 16 ripple counter. It's ripple because it's not synchronous, right? If it were synchronous, then I'd have the clock would all be hooked together, and it's counting to 16. And then we do a down counter. Now how come the down counter is counting down? Oh, I see. Isn't that cool? So we're going to do a down counter. All we're going to do is measure the Q naughts. All right. So that's what we're going to do. We're gonna get rid of this guy for a moment. Change the speed back to 10 hertz so that human beings can see it. Now, why is 10 hertz not very fast? Anybody figure that out? I mean, 10 hertz should be pretty fast, right? 10 times a second. So I turn this guy on, and that guy there doesn't look like he's flashing 10 times a second anymore. Doesn't look like he's doing diddly or a squat. There we go. Yeah, the yellow guy's not, what's going on? The yellow guy's not flashing 10 times a second. What'd I do? Got a long sleeve on? Something up it? If I look over here on the bottom, see that where it says time? And we're coming up on 2 seconds into the simulation here, 1.8, 1.9, 2. Okay, so from that to, it's been about 5 seconds already. There's 10 seconds. And there's 15 seconds. It's about 20 seconds to get 1 second in. It's going to take the computer time to simulate the problem. So the time of the problem is being generated on the bottom of your multisim, telling you how fast you're going in real time. So that's why I can put 10 hertz and see it flashing less than a 1 second rate. But it says that the guy in 546 says if I hook up the indicators here to the not guy, then I'll have a backward counting counter. I wonder if there's any truth to that. Must be true. He wouldn't have put it in the book, right? All right, I'm going to turn it back on. All right, there's 15, there's 14, 13, 12, 11, 10, 9, 8, yeah, I guess so, 7, 6, 5, 4, 3, 2, 1. So now I have a backward counting counter. All right, well, I can count backwards, I can count forward. Now I decide that I got this counter and it's going quite well and everything's going well. But I don't want it to count to 16. I'm only going to want it to count to 9. How am I going to do that? Okay, so I'm gonna put my indicators back up on top so that we're positive counting again, and I only want to count to 9. I don't know why I'd want to do that, but I do it. All right, so what we're going to do, turn it off. When I get to 10, what do I want it to read? 0. And a 0 is sort of like a reset, right? So if I decode a 10, when I get there, I'm going to reset it. Okay, so we'll get go to well, we won't do anything because this thing is still doing that. Okay, so TTL. And anybody remember what our 4 input AND was? Four, there's a 3, 7421. Okay, 7421. And 7422. 7421. Okay, so there's a 7421. And but we want it to be a naught, so we'll go and put a 7404 next to it. All right, that's good. So how are we going to decode a 10? A 10. So this is 8. And 0, 1. I put that guy in the wrong spot, didn't I? I want him to be on the Q naught guy, so this guy is in the wrong place. We want him to be over there. So I'm decoding a 1, 0, 1, 0, which is a 10. And when I get a 10, I want to reset. Okay, now this is going to be interesting. How are we going to get it going the first time? If I send them up here through, send them there, wrong spot, there like that, and I send them into the reset guy, but then I've got him going into the reset guy. Can I have them both doing it? I don't see why not. All right, we'll try it. All right, so we're going to turn it on. So there's a 1, a 2, a 3, a 4, a 5, 6, 7. This is so boring. 8, 9. I better see a 0 next. 0. Aha! I did it. So I made a 9 counter by having a 16 counter and just resetting at 10. Oh, okay. So I can do that. Let's see if we can, we're up to, where are we? 12-3. So let's look at the homework problems real quick and see if we have any 12-1 or 12-2 homework problems. Yes, we do. Okay, so the other issue is, do we have any 12-1 or 12-2 homework problems that are assigned to do? That would be the other issue. So I look in, we're supposed to do 12-2. Okay. The waveforms shown in figure P12.2 are applied to A, D0, and C. Sketch the resulting waveforms D, Q, Q0, and X. I guess I'm going to have to turn the page. What do you think? We're going to have to turn the page. -2. Okay, so I got it. All right, so I've got 6 clock pulses. 1, 2, 3, 4, 5, 6. No, I have 7 clock pulses. 0, 1, 2, 3, 4, 5, 6 for 7. Okay, and then I've got the RD guy, RD naught guy, and it's going to start low, and then it's going to go high, and it's going to stay there forever. So that means we're going to start with a 0 at Q. The A guy is doing something weird. Okay, so the A guy is going halfway through 0 and going up. A little bit through 1 and going down. Going to go up and down in almost the middle of 2. Going to go up before 3, stay there until after 3. And then going to go up during 4, and then stay there for the rest of the time. Okay, I have a positive going clock. Positive going clock. Okay, so if anything changes, it's going to change there, 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 there. Why is this a different color anyway? There, there. All right. Be nice if my clock was prettier. Okay. Okay, which came first, the chicken or the egg? Okay, so we're looking at what D is, what Q is, what Q naught is. I know what Q naught is, it's whatever Q isn't, and what X is. Alright, so I put those two close together. Alright, so, but I know what D is at the beginning. So D is going to be low because of the R naught guy. And it's going to stay low until potentially the first guy there. Okay, and the Q, because, well, no, I don't know what the D is. I have no idea what the D is. But I do know that the Q is low and the Q naught is high. I know that. All right, now I've got to figure out what is X. X is A or Q. Q is low, so X is going to be low. If X is low, then D is going to be low. All right, now I'm set. So D is low, Q is low, Q naught is high, and X is low. The clock pulse happens. Nothing changes. So I stay, I stay, I stay, I stay. A goes high. A goes high, which means X goes high. X goes high, which means D stays the same. D stays low because Q is still low. But if Q that's Q naught. Wait a minute. D is X or Q naught. Okay, so D is X or Q naught, not or, and. And Q naught. Okay, so that's a horse of a different color. So when X goes high, Q naught is high, so D is going high. Nothing can happen to Q or Q naught. Q is low, Q naught is high, until the clock pulse. Okay, so that's going to happen. That's X is going to stay there. The clock pulse happens, and Q goes high, and Q naught goes low. With Q naught going low, X is going to go low. No, X isn't going to go low. With Q high and A high, X is going to stay high until A goes low. When A goes low, it doesn't matter, it's still going to be high. Okay, but D is going to change. So D, when A goes low, but Q naught is low, so D is going to go low as soon as Q naught goes low. Okay, got that. What's the next thing that's going to happen? Absolutely nothing. We're going to come over to there. We're going to come over to here. We're going to come over to there. We're going to come over to there. Okay, now, the clock pulse happens, D is low. Because D is low, Q goes down, Q naught goes up. A spikes in there, so something happens to X. X goes down, then X goes up, and then X goes down, and then X goes up again. Okay, but nothing happens to Q, nothing happens to Q naught. What happens to D? Q naught is high, so when X is high, D goes up. So D is going to spike there, and D is going to spike here and stay high when the next clock pulse happens, in which case Q goes up, Q naught goes down. Because Q naught goes down, D goes down, X stays high all the way across. All right, almost there. All right, a clock pulse happens. D is low, so Q goes low, Q naught goes high. X. A is low, Q is low, X goes low, X goes low, so D stays low. When A goes high, X goes high. When X goes high, D goes high. Right, so D is now high when the clock pulse happens. All right, clock pulse happens. D is high, so Q goes high. Q naught goes low. A is high, so X is high. X is high, Q naught is low, so D is going to be low coming into the next clock pulse. The next clock pulse happens. Q goes low, Q naught goes high. X is A, so X is going to stay high. D is going to go high, and we're done. No more clock pulses to worry about. Thus goes problem 2-12. I could build a circuit and put in a switch so I could change A, and if I was quick about it and did it at the right spot, I could have it show that, right? But I'd have to be pretty cool if I was going to do that. All right, back to what we're doing. 12-6 is still in the ones that we did. Okay. What is the modulus of the counter whose output counts from? All right. This looks like a typical question that could be on a test because it's so pathetically easy. 12-6A. All right, so I'm counting 0 to 7. What's my mod? 8. 0, 1, 2, 3, 4, 5, 6, 7. I have 8 fingers that I touched. B, right? This is a finger touching exercise. B. 0 to 18. Now I got to get my toes out. Mod 19. C. 5 to 0. Mod 6. D. 10 to 0. Mod 11. E. 2 to 15. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Mod 14. I have 4 fingers on this hand. Mod 14. Want me to do it again? Mod 14. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Only one little pinky left. Mod 14. Got that? That's graduate school. You get that in graduate school. F. What's F? 7 to 3. 7 to 3. 7, 6, 5, 4, 3. Mod 5. So the mod has nothing to do with the biggest number there or the smallest number there. It has to do with how many states you had total. That's what it has to do with. Okay? Do we have another one? 12-8. Yep, 12-8 is still in our problem set. Okay, so 12-8. If the input frequency of a 6-bit counter is 10 megahertz, what is the frequency of? Okay, so we have 10 megahertz coming in. And we have A, B, C. This is another question that's going to be on the test, by the way. D, E, and F. And we want the units place, the twos place, the fours, and the threes, and not the 3, the 8 to 16s, and the 32nd place. Okay, so those are the places. All right, so if I'm coming in 10 megahertz, and I look at that guy, I'm going to have 5 megahertz. And if I look at that guy, I'm going to have 2.5 megahertz. You see a pattern yet? And if I look at that guy, I'm going to have 1.25 megahertz. Yeah. And if I look at that guy, I'm going to have 0.0625 megahertz.
What's the math on that though?
And I'm dividing by 2.
No, like, but if you have like a different number, it's not.
Oh, if I started with 20 megahertz?
No, if you started with. I mean,
If I started with the 4th place instead of then the answer would be down here in the 4 one. And in fact, on the test, we're going to go 0, 1, 2, 3, 5. And you're going to put down the 4 answer instead of going to 5. Yeah, you're gonna do it. I just feel it in my bones. 0.3125 megahertz. 0. I don't know. Do I have the calculator up?
What is it?
Where's my calculator? 3125 divided by 2. Alright, so 15625. 15625 megahertz.
Like, is it 10 megahertz divided by 2 to the 5th power?
No, to the 6th power, because when it's a 0 term, I divide by 2. And when it's the first term, I divide the first guy by 2. So this is really 2 to the 4th, right? So this guy here is not 2 to the 5th. I'm dividing by 2 to the 6th. Now, why is that? Well, because my input signal is doing this, right? And how often does that unit place change? It's doing that. It's dividing by 2 already. So the first output it divides by 2 already. It's the first place. It's the units place, so it's going to divide by 2. It's not going to give you the signal back. So we come back to, where is it? That guy? No, not that guy. Come back to, which one had a clock? So this one had a clock. And, but I really don't have a most significant bit, so. Yeah, there we go. So here's my clock, boom, 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 going up and down, up and down, up and down. I'm dividing by 2 already on the first output. So the clock has to go down twice in order for me to get back up once. So that's why the divide by 2, the 2 to the 0 spot coming out, ends up dividing by 2. Or words to that effect. Okay, do we have another one? 1213. Oh, bummer. Oh, well, we can do 1213. We'll do it anyway. We haven't really finished that section, but it's so pathetic that it's pathetic. A, B, C, D. How many flip-flops are required to do a divide by 4? Divide by 4. No. 2. How many do I need to divide by 15? 4. How many do I need for divide by 12? 4. How many to divide by 18? 5. All right, so if I want to divide by 2, I can do that with 1 flip-flop. I just showed it to you on the other page. If I want to divide by 3 or divide by 4, it's going to take me 2 flip-flops. If I want to divide by 5, 6, 7, it's going to take 3 flip-flops. 8 to 15, it's going to take 4 flip-flops. Okay, so think of it in binary. If I'm going to, so here's 2. If I'm going to divide by 2, I only need 1 flip-flop. But a 3 looks like that. I need 2 flip-flops, 1 for that position, 1 for that position. And a 4, I need 3 flip-flops to do the 4. No, I don't need 4. 0, because 0, 1, 2, 3. I can do it in just 2. Okay, so all right. Was that confusing enough?
Did you say you could do 4 with 2?
Yes, I can do 4 with 2 flip-flop because I only count 0, 1, 2, 3, back to 0. There's 4 right there. 0, 1, 2, 3 is 4. So I have a state 0, I have a state 1, I have a state 2, I have a state 3, then I go back to state 1. So if I have an incoming signal and I divide by this and I wait for the 0 to happen, the 1 to happen, the 2 to happen, the 3 to happen, and then I change it, and then I wait for the 0, 1, 2, 3, and I change it, then that's a divide by 4. Yeah. Isn't it wonderful that you learned to count binary earlier in the semester? Just one of those things. Okay, well, let's call it a day. I think we made it far enough through that problem set.